Welcome everyone. Thank you for joining. We will start in about 3 more minutes. I just want to let you know we are here. We'll start in 2 more minutes actually. So just hang on tight. And I also want to remind you to please keep the chat clean to avoid being removed from the webinar. Thank you. Okay, everyone, it is 4 o'clock, so we're going to go ahead and get started. Hello, and thank you for coming. My name is Miss Lorena. I am a librarian here at the Central Park Library with the Santa Clara City Library System, and I will be moderating this event today. I just want to remind you to please keep the chat clean or you will be removed from the webinar immediately. So please keep any comments, if they're mean comments, just keep them to yourself. Also, we have some friends watching on YouTube. So my friends on YouTube, you can use the chat as well. I'll be monitoring both chats. If you have any questions throughout the program, Maida will go through the program with you and she will ask you questions. Feel free to use the chat to answer those questions. I also want to remind you that this is a webinar as opposed to a meeting, which means that participants are not allowed to join in with video or audio. We do this for safety. It is a public program open to everyone. So you will only see Maida on your screen. Other than that, if you have any questions, please let us know in the chat and I'll be here to answer them, and I will hand it off to Maida. Thank you to Maida. She is awesome and she's going to be teaching our class today.
Thank you. So hi everyone, my name is Maida and I'm going to teach on behalf of the Science is Fun program. It's a program I started about 3 years ago at many other libraries, and now we've expanded to the Santa Clara Library so we can teach a lot more of you guys. So if you're interested in knowing more, I will also link our website in the chat and then you can take a look. So now I'm going to share my screen and then you should be able to see my presentation over here. Really quick before that, here is our website. It's at funscienceforkids.org, where you can get a lot of information about the program. So here, of course, is all the places we're holding the program. If you have any questions after we finish this webinar, go ahead and go to the Contact Us button, write your name, email, send us a question or a message, and we'll respond within 24 hours. And one quick other thing is that in this program, you'll be learning over here, physics, biology, and anatomy. I am your first instructor. You'll also be getting 2 more later. One thing we don't have is physics and chemistry. So if you're interested in physics or chemistry, then go ahead and send us a message. And then maybe we can get our physics, chemistry teacher, and then they can also teach one segment. Okay, so our topic for today is refraction. So let's get into it. Again, if you have any questions, put in the chat, and I'll try to answer as soon as. And we're waiting for this to load. Okay, let me stop sharing and try again. Let's try. It looks like I'm having trouble with the share screen because when I'm not sharing.
Yeah, I think Maida's
Okay.
computer froze. Can you tell me in the chat if you guys can see her or hear her? I see. Maida, can you hear us okay? Okay. Let's give it a minute. Hopefully Maida will be able to join back. Looks like she froze, so give it just 1 minute. Let's see if she can come back. Looks like she was removed, so I think she lost connection. So just hang on tight 1 more minute and hopefully we'll be able to start.
Okay, I'm back. I will try again.
Let me know if you need me to share your slides for you, Maida.
Okay, finally. Okay, so now we can finally get started. So refraction. Refraction is the bending of light. So that's the scientific term. And that's what we're going to go into today. Okay? Okay, so we're going to start off with what is light. So if anyone wants to answer that, go ahead and put it in the chat. So what is light? Any examples or anything that you know? And I see someone's raised their hand, but we won't be able to call on you directly. So you can just put that into the chat and we'll look at that right there. Light is brightness. Okay, yeah, that's correct. Energy, yeah, that's correct as well. The fastest type of energy, yeah, we're getting really good answers. Any last answers before I actually tell you? The sun, the burning of gases, great guesses. Like the sun, yeah, okay. I see someone has named themselves with my name, so can you like change that back to your original name, please? Thank you. Okay, so what is light? Light is a ray. Okay, so there's many theories of light. Some people believe it's a particle. Some people believe it's a ray, but we're going to go with the ray theory because that works best for what we're talking about today, which is the bending of light. Light travels in a straight line in one medium, and a medium is a substance. So glass is a medium, water is a medium, air is a medium, your table is a medium, the water in the swimming pool is a medium. So light travels in a straight line in one medium. Light is the fastest thing in the universe. In space, the speed of light is 300 million meters in 1 second. And as a comparison, the fastest cheetahs run about 30 meters in 1 second. So light is about 10 million times faster. So you can imagine, it's very fast. Okay, I'm seeing questions. Oh, okay, that's your name too. Okay, that's cool. I've never actually seen anyone with my name, so that's really cool. Okay, So let's move on. If anyone has any questions, put them in the chat. Okay, so now we're going to actually talk about the bending of light, which is refraction. Okay, so here we have two examples. If light falls straight on a substance, it will go straight. So let's say you have light traveling in one medium or substance, in the second substance or medium, which is our glass. So if the light comes in straight, it'll come out straight. Okay, so that's one rule of light. Now our second rule is with refraction, is that if it comes in at an angle, now here originally it came straight, but now we're coming in at an angle or kind of diagonally, we're going to have the light bend. Okay, so normally if it didn't bend, if it didn't change substances, it would go this way, but it's not going this way. It's going to start bending, and that is what we're talking about with refraction. So as you can see here, light falls straight, it'll go straight. Light comes at a medium, it'll bend, and this bending is refraction. Okay, any questions? Can light travel before you blink? Yes, because light is the fastest thing in the universe. You blink and it's already gone many meters. Yes, so that is true. Great question. Okay, next. Why does refraction happen? So we know it does happen, but why? Why does that happen? So it's all have to do with speed, okay? So imagine you are running on air and your friend is swimming in a pool next to you. Who's gonna reach the end faster? You are, because in your medium, which is air, it's a lighter medium, so you're able to move a lot faster. But your friend swimming in that pool, they're a lot slower because their speed is slowed down. So the same thing goes for light. When light moves from one medium to another medium, its speed changes. So in a heavy medium, the light will slow down more than in a light medium. Not a light medium, but like a lighter medium. The shortest time. But again, light wants to be the fastest in the universe, 300 million meters 1 second, right? So it's going to have to bend. Another way to think of it is you're on your way to school and you see a bunch of mud in front of you. You're not going to go through that mud directly. You're going to bend around it because that's just the way you can go fastest and stay clean also, right? Okay. Does it create a faster speed when it bends? In a way, yeah, because if you bend outward and you get out of that medium faster, in the end, you're going to be able to reach whatever you want, wherever you want to reach a lot faster. So it's not necessarily it's having a faster speed, but it's getting out of that slower medium faster. Now, what's the closest speed of light? What's the closest thing that has the speed of light? I think sound is kind of close, but sound is still, you can beat sound, the speed of sound. So we should research into that, what's really close to the speed of light. But definitely light is the fastest. Okay. Next, we're gonna watch this video. So let me know if you can't hear it, but I think you should be able to. It's a pretty fun video and it's gonna go back into refraction. Okay.
Topic, refraction of light.
Huh?
Why does a pencil look bent in water? Wow, that was a very cool magic trick. Now check this out. Oh. Hey, stop crying. Your magic wand is not bent or broken. Look, it is safe. But do you know why your magic wand appeared bent in water?
Huh?
Oh. It is because of refraction of light. Refraction of light is the change in direction of light when it passes from one medium to another obliquely. So, what do you think are the two media here? You don't know? No worries. I will tell you. They are air and water.
Oh.
When the light rays coming from the tip of the magic wand pass from water to air, they change their direction. That is, they get refracted. When these refracted rays reach our eyes trace them backward as straight lines. Due to this, the rays appear to come from a point slightly above the original position. Hence, the magic wand appears to be bent in water.
Oh.
Similarly, like the magic wand, a pencil appears to be bent in water.
Okay. Let me go back into the full screen. Okay, so that basically tells us that refraction is the reason why a pencil or that magic wand looks bent in water. So you can actually try that experiment at home. So just take a glass of water, put a spoon or a pencil in it, and then you'll see that it looks bent because that refraction happens. So when the light goes into that water, it has to bend because it has a speed change. Okay. Now here's another place we can see refraction, which is in rainbows. So let's start off by the phenomenon of colors coming from white light, okay? So we start off with a triangular prism. So I'm sure a lot of you have seen this picture before, but why does that happen? Okay, so we have some white light going through here. But the thing is, white light is actually made of all of these colors because white is actually all the colors mixed together. So in white light, we have all of these different colors of light, but the problem is they all have different speeds. So when they start bending in the glass, what's going to happen is the red is going to bend a little bit less because it doesn't have much of a speed change. But the purple is going to bend a lot more because it has more of a speed change. So in this way, all of the colors are going to start bending a little bit differently. And then we see it start splitting up, and then we get a rainbow out of it. Now, how does this effect happen in real life? So you'll notice that rainbows, they always happen after it's rained. And it starts when the sun comes out and it's rained. What happens is there's a lot of water droplets in form of water vapor still in the atmosphere. So those water droplets act like prisms. So you can see here, we have a little model of that. So we have sunlight coming in here. Now sunlight is white light, which then becomes refracted. So we see all of these colors starting to split up. We have a little something called reflection happening, which we'll learn about in a little bit of a different topic, but refraction happens, a little bit of bending happens here, and then another form of refraction happens because from water to air, that's another medium switch, and then we get a rainbow out of it because all the colors start coming out. Okay, now let's look over here. So we have white light coming in, the colors split, and they come out, we get a rainbow. And that you can see over in this picture. Why do double rainbows happen? So what happens to the double rainbow is the light comes through, then it bends 2 times. And because it bends 2 times, the colors are flipped. So as you can see here, purple was on top and red was on bottom. Now we have red on top and purple on bottom. So what we get is we get one of these, and we get another one of these, and then we get a double rainbow. And a lot of times you'll see that in a double rainbow, the bottom bow is the right way, and then the top one is in the inverted way. Okay. Yeah, unstable connection. Should I repeat what I just said? If anyone couldn't hear that? Okay, I'll repeat what I said. So I think it might have cut off around here. So again, the light comes through, and then the light starts bending. And because it starts bending, the refraction, it splits into all of these colors. And then it comes out, refracts one more time because there's another medium switch, and then we get all our colors. Same thing happens in the rainbow, and then in the double rainbow, it bends 2 times. And because it bends 2 times, we get an inverted rainbow on top. Okay, so hopefully you heard that in case my internet connection went out. let me know if that happens again and I can repeat whatever I said. Okay. Okay. Which part did I cut off on? Whoever asked for me to repeat. Okay, another question, can light pass through anything? No, it actually can't. Some substances which are opaque, light can't pass through those. So there's translucent, transparent, and opaque. Transparent substances is light can pass through all the way. Translucent, some parts can pass through, and then opaque, no light can pass through. So those are just examples. Okay, the middle part. Okay, I'm assuming, so I'll repeat that. So we have white light going in, then we have the refraction happening over here, form of refraction here, which splits that light more. So then we get our rainbow. And then in the double rainbow, it bends 2 times, and you'll see that the red is on top and the purple is on bottom. And here it was the purple on top, red on bottom, which is why the colors are inverted, flipped. And then you'll see that rainbow here. Okay. Any more questions? Okay, so can I move on from this slide if everybody heard that? Or if someone didn't hear something, I can repeat if they want. Okay. Okay, so whoever said yes, can you tell me which part you want me to repeat? Which picture, if that could help? No? Okay, I'm gonna move on and I'll come back if you need it. Okay, someone said 2. The second one? Are you talking about this one? Yes, no? Yes, okay, this part. Okay, so we have white light from the sun coming over here. Then we have refraction because, we were coming from air. Now we're going into water, right? So we have reflection. Don't worry about that right now. And then we have more refraction because we're going from water to air. So we get all the colors to split out. Okay, do we need light to see? Yes, you need light to see. If we didn't have light, we would just be bumping all over the place because light pretty much allows us to do all the work that we do. So yes, light is very important in that way. Okay, I'm going to move on. Next part of refraction. This is a very important part, which is lenses. So lenses is how man uses refraction to fix problems around us. Okay, what is a lens? And what are some examples? I have some examples on this page if you want to just tell me what those are. Anybody? I see glasses. Yeah, glasses. We have glasses here. I'm wearing glasses right now. Anyone else? What is this? Yeah, I see magnifying glasses. Yep, that's over here. Contacts, contact lenses. Yes, so these are all forms of lenses. Magnifying lens, glasses, contact lenses. So what is a lens? Let's see. A lens uses refraction, or the bending of light, to bend light in different ways. And it could be made with plastic, glass, or other materials. I think typically glasses are made of more of a plastic material for kids, so that if you drop it, not much happens. Some magnifying glasses are made of glass, some are made of plastic, again, to keep it safer. Contact lenses, I'm not exactly sure what they're made of, but I think they are a little bit more of a stretchy, bendy material. Yes, and lenses are in your eyes, and we're actually going to talk about that in a little bit later. So good job. Okay, let's move on. So there's 2 main types of lenses. We have a convex lens and a concave lens, okay? So here is our convex lens. So what a convex lens does is when the light comes straight, it does not go straight through because even though it looks like it came straight to you, what happens is the edge of it is slightly bent right? So it's not a straight surface. So technically light is not coming at a straight angle. It's coming at a different angle, which causes it to bend. And because it's a convex lens, it'll bend downward here and upward here. It won't bend here. And it all meets in one point called the focal point. Now that's an important concept for us to talk about a little bit later. So with the focal point, all the light comes together and it meets here. And a convex lens is also called converging because it brings all the light together. So convex, converging brings light together, okay? Now talking about the concave lens. Now, does anyone have any idea how we can remember that it's concave? I'll give you a hint. It's in the word. Anybody know? I'll give you 5 seconds. Okay, I see a chat message. Cave, yes, that's correct. So this part looks like a cave. So concave, we have a cave there. Okay, more chat. Yes, cave. Whoever said cave, yes, that's correct. So again, we have light coming straight, but it's bent at a slightly different angle compared to this one. This one's bent this way. This one is bent this way, okay? So the light will go outward. So here it'll go up, here it will go straight because the light actually came straight here, and here it will come down. Now, this is also called a diverging lens because all of the light is spread apart. It's not brought together. Now, the problem with that is there's no point where the light comes together. So how do we make a focal point? Because scientists need that focal point to do a lot of important calculations. So what they do, they backtrace. So this is an imaginary focal point. So they backtrace from all the lines that came here, and then they form this imaginary focal point, which they can use later for all their calculations and all, and we'll talk about that a little bit later. Okay, any questions on this part? Is it called cave? It's called a concave lens right here. Concave and convex. So you can remember that because it looks like a cave. Any other questions? Okay, very good. Chat. Whoever asked, okay, what lenses does a magnifying lens use? A magnifying lens depends. I think typically they use a concave lens because it'll make whatever's small on one side big on the other side, but I'm not completely sure on that, so I'll come back to you. Okay, any other questions? What lenses do glasses use? Very good question. We're actually going to go to that later because what happens with that is there's many different kinds of glasses. Okay, shall we move on? Can light travel before you blink? Yes, light is very fast, fastest thing in the universe. So faster than you can blink, faster than you can clap, faster than you can say something. Light is fastest. Okay, did I cut out for that last part? No? Okay, let's move on. Okay, we have a Bill Nye the Science Guy video to show you a little bit more of how this whole refraction happens. Okay.
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
This magnifying glass is making my eye look big. Now, why is that?
I don't know.
Please consider the following. When light enters something like air, water, glass, or plastic, it slows down a little. And when it slows down, it changes direction. See how one eye is lower than the other? See? Take a look at this. Here are 3 straight beams of light. When they go into the piece of plastic straight, they come out straight. But if the plastic is tilted, the beams of light get tilted. See, they change direction so that they come out this side offset. Now, what would happen if the piece of plastic didn't have straight sides, but had a curved side, like a magnifying glass? Well, the light would change direction, right? Because the surface of the plastic is curved, each beam of light enters the piece of plastic at a slightly different angle, and it changes direction a slightly different amount. Look, over here, the beams of light come together at a single point. This is called the focal point. Now, what about the magnifying glass? Well, suppose your eye were over here, and light from the room were bouncing off of your eye and going through the piece of plastic this way. Well, then, the small area this end would be over a large area on this side. Your eye would be magnified. Thanks for joining.
Okay, so actually that answers one of our questions that we had, which was what lens does a magnifying glass use? And that's actually going to be something that we haven't learned about yet. So that's a Plano convex lens. So I actually have an example that I will show you later, but Plano convex. Okay, it was cutting off a little bit, the video. Yes? No? Okay. Basically what they were saying is that light coming through that Plano convex lens all converges to one point, which is the focal point. And if your eye is there, then whatever you see on the other side is magnified. Okay. Would anyone like to watch that video again to see if that helps?
Maida, I can also stream it from here. My internet connection is pretty strong, so if you want to send me the link, I can stream it from my computer if you want.
Okay, sure. Let me grab the URL and then I will send it to you. Okay, yeah, I've sent it to you. Okay, so I'm seeing that maybe.
Yeah, you want to see it?
Can you repeat that?
Yeah, I can play it again. I'll play it again right now. So give me a second. Let me get it set up for you guys.
Okay.
So let me make sure you can hear it, okay? I'm going to share my sound as well. So give me just 1 minute.
With Rennerly's help, is writing an email to his boss, Anita.
Can you guys hear that okay?
Yeah.
Yeah, okay. Let me share my screen and then we can watch it again. I'm going to stop sharing your screen, okay?
Mm-hmm.
Oh, wait. Hold on. Let me share my screen. There we go. Okay. You see it okay?
Yeah.
Okay. Let me play it.
The science guy. Bill Nye, the science guy. Bill Nye, the science guy.
This magnifying glass is making my eye look big. Now, why is that?
I don't know.
Please consider the following. When light enters something like air, water, glass, or plastic, it slows down a little. And when it slows down, it changes direction. See how one eye is lower than the other? See? Take a look at this. Here are 3 straight beams of light. When they go into the piece of plastic straight, they come out straight. But if the plastic is tilted, the beams of light get tilted. See, they change direction, so they come out this side offset. Now, what would happen if the piece of plastic didn't have straight sides, but had a curved side, like a magnifying glass? Well, the light would change direction, right? Because the surface of the plastic is curved, each beam of light enters the piece of plastic at a slightly different angle, and it changes direction a slightly different amount. Look, over here, the beams of light come together at a single point. This is called the focal point. Now, what about the magnifying glass? Well, suppose your eye were over here, and light from the room were bouncing off of your eye and going through the piece of plastic this way. Well, then, the small area at this end
would be spread out over a large area on this side. Your eye would be magnified. Thanks for joining me on Consider the Following.
Bill Nye the Science Guy.
Hey, you need to.
Perfect.
Okay,
If you have another
Great.
video, Maida, just let me know and I can play that too, okay?
sure. Okay, let me share. Okay, let's move on. So now we're going to talk about refraction in the eye. Okay, so someone before did say that there's a lens in our eyes, correct? So very nice job. So here, this lens is not made of glass, or what happens is, let's say there's a person standing here. What's going to happen is the light coming from the person's head is going to go into that lens, okay? And since it's a concave lens, convex lens, it's going to bend downward. And here, light coming from here, going to bend upward. Now, does anyone know what this point is called? Does anyone remember from the video? Okay, focal point, yes. So this is the focal point where all the light meets. So thank you for whoever said that. Thank you. So we have the focal point, and then the light will continue going down, and we get an inverted image. So it's upside down. Yes, that is refraction. This is refraction over here. So what happens is, this is a place in our eye called the retina. Now the retina is where the image is captured. Then the eye sends that image to the brain through this place called the optic nerve. Now the optic nerve sends that message to the brain. The brain flips the image one more time, and then we can see that, okay, there's a person over there. Okay. Yes, someone knows retina? Good job. Okay, I'm seeing more questions. Blue light glasses, what can they do for our eyes? Blue light glasses, I believe they just help you, help your eyes feel less tired, because in your computer, there's a lot of red light, and I think it's kind of combating that. I'm not too educated on that, but I think it does help with computers and all of that. Can sunglasses have refractions? No, sunglasses, they don't have refraction. Refraction is only needed for correcting vision. Sunglasses are just tinted clear glass, so no specific shape with that. Do we do one about gravity? Not yet, no, but if you request that in our contact us section, we can make one for you and we can do that. So if you have any other ideas about topics you want to learn about, go ahead to our website, put in the contact us, and we will try to make that happen. Any other questions? Okay, we're good. Let's move on. So, eyesight problems fixed with refraction. So here we're going to go over the three main eyesight problems. So let's start with the first one, which is myopia, nearsightedness. So you can see things that are close to you, not so much the things that are far from you. Okay, so what happens is, we go through, the light goes inside, then it bends with our lens, but the problem is if the focal point comes too soon, it bends too soon. So instead of coming here, the picture is showing up here. So it's not exactly touching the retina. Now that's an issue because you will see that image blurry. So what we have to do is you have to wear glasses or contact lenses. And here we solve this problem with what type of lens is this, everybody? Put it in the chat. I'll give you a hint. It looks like a cave. Anyone know? No? Nobody knows? Okay, we got some answers. Concave. This is a concave lens. So light goes through, it bends. The light has to bend a little bit more. So our focal point is in the right spot. It's here instead of over there. So now it's going to bend all the way, and we're going to hit the retina properly. We're going to get a clear image, and our brain's going to see it properly. Okay. Yes, it is concave. Thank you. Okay, so that is myopia. Myopia is a pretty common condition because seeing close things. Maybe you can't see the whiteboard at school. A lot of kids have it, not so many adults. Now, hyperopia is a condition that's typically seen with older people where for some reason their lens has lost a little bit of function, it can't bend as much, so they have this issue where they can see things that are pretty far, but they can't see things that are really close to them. Okay, so what happens is light comes through, it bends, but the focal point comes too late. So what happens is it keeps bending and then the image shows up here, which is beyond the retina, it's imaginary. So that's an issue. Now, how do we solve that? What type of lens is this? Okay, is far away things blurry for people with myopia? Yes, far away things are blurry. Okay, what type of lens is this one? This was concave. Does anyone remember what this one is? No, this one's not concave. This was concave. So does anyone remember? What's the other one? Convex, yes, we got the right answer in the end. So this is a convex lens. Now what this is gonna do, it's gonna bend it a little bit closer. So now the focal point will come at the right spot instead of over there, and we're gonna bend at the right spot. We're gonna hit the retina, and we're good. So that's very helpful. Now we have a little bit more of a complicated scenario, which is astigmatism. Okay, so with astigmatism, what happens is this is a condition from birth, it's genetic. And what happens is your lens is shaped a little bit weird. Okay, so what happens is the image comes over here, focal point's fine and everything, but it's diagonal, and that's very weird. So what we have to do, we have to give this kind of lens. And I don't exactly know what this was called, I don't remember, but it's a special lens where this part will stay pretty much constant, but this will bend a little bit more so that we can get it to there and we get the nice image. Yes, astigmatism is a little bit complicated. And actually the fun fact is I have astigmatism because I have a genetic thing where the lens of my eye is kind of misshapen. So this actually happens in my eye where it'll kind of look like this. So near things are pretty good, but far things are kind of blurry for me. So I have nearsighted astigmatism. You can also have astigmatism, which is another thing, but this is what happens for me. And my glasses are actually shaped like this. So the top of my glasses are a little bit thicker than the bottom. Now if you have glasses, you can kind of test it out with yourself, see if it feels, figure it out. But if you have a low power, then it will be harder for you to have a kind of in the middle power with them. So I can actually feel the difference, but it's not too obvious. Okay, someone says they have myopia. So check out if you can have glasses, if your glasses look like this. Okay, someone says I'm stuck. Am I stuck now?
Yeah, your camera stuck, but we can still hear you. It's a little bit choppy, but your image
Am I
is
stuck?
Yeah, do you want to maybe stop your video and try again? There we go.
Okay, maybe I can change. Yeah. Is it good now?
No, I can't see you. Maybe others can. Oh, there you are. Okay, I see you now.
Am I still frozen?
Yeah, a little bit. If you want to, maybe just you
Okay.
can turn off your camera if you want, and then
Can you hear my voice fine?
we can hear your voice. Yes.
Okay. Yeah. I can also. Okay. Let me see chat. Yes. Okay. Great. Then we'll go like this. Okay. So we're gonna try some stuff for ourselves now. So, any final questions on here? Nope. We're good. Okay. So I'm gonna stop my share. Let me just keep this. Okay, and now can everyone see my other screen over here? I'm going to spotlight that, and it looks like this over here. Yes? Okay, great. So we're gonna do the fun part of this whole lesson. We're gonna play with some lenses. So here I have, what kind of lens is this, everybody? Does anyone know? Convex, yes, that is correct. What kind of lens is this one? Concave, nice. Okay, now what is this? This one right here. Yes, that is a triangular prism. Now let's go to the next one. We have this. Yes, it's a rectangular prism. Okay, and lastly, we have this. What is this? Does anyone know? You can take a guess. Semicircle prism, good guess. Half circle, good guess. You don't know? Okay, so this is actually a plano convex lens because it looks very similar to this convex lens, but it's flat. It's flat on this side, which is why it's called a plano convex lens. Okay, so can you all still hear my voice properly? No? Okay, I can change my Wi-Fi and maybe that will help. Let me see. Okay, can you guys hear me now? Yes? Okay, great. So it looks like my Wi-Fi now is working better. Okay, yeah, I was using a hotspot earlier. So can you guys see me well now? Yes, okay, great. So what we're gonna do is we're gonna have a little bit of a fun time now. So let me move this back a little bit. Okay, so we're gonna actually do some experiments with this. So I've got lasers, laser pointers. Okay, so I have green, I have a purple color, I have red, and I have this other green. And what I do every time is I allow you guys to choose which lens you want. So who wants which? Do you want red or green or purple? Which one do you guys want? Red, I'm seeing red. Okay, I'm seeing purple. Purple and red. Oh, a little bit of green in there. Some red, some purple. Okay, so what we're gonna do is I'm gonna give each of you guys an opportunity to pick your own lens, pick your own combination, and we're gonna have some fun with it. So I'm gonna start, and I think I will start with the green, because I like the green. So what we're gonna do is, let's first test out that the concave lenses, convex lenses are working well. Okay, so we have a lens here, and I'm gonna take this laser, and I'm gonna point it this way. So what do you think is gonna happen? Is it gonna go straight? Is it gonna go up? Or is it gonna go down? What's gonna happen? Straight, up, down. Just give me your answers in the chat. Yeah, it will bend. Okay, I'm hearing up. I'm seeing down. Up and down, maybe, straight. Okay, some people don't know. Let's see. Okay, so we're gonna go in. Looks like my laser is dying. We're gonna pick another one. What's happening? Someone write it in the chat. What's happening? Is it going straight up or down? Up, yes, that's correct. Because in the diverging lens, it's gonna go up. Now, what if I put it here? Straight up or down? I'm seeing some up right over here. Some straight, yeah. Straight. Let's see what's happening. Okay, what's happening, everybody? Tell me. Straight, yes, it is going straight. Now, final one, down here. Up, straight, down. Down, yeah. Anyone agree? Down, some up, down. Let's see. What's happening? It's going down. So if I were to move this all the way, look at that. That's cool, right? So again, diverging. All the light's gonna go every other direction. Now let's try it with this lens. What's this called again? Anyone remember? The other one is concave, so this must be convex, yes. So if I send the light going this way, up, straight, or down? Up, I'm seeing some down, seeing more down, a little bit of down, yeah. Some straight, okay, let's see. What's happening? Down, yes. Now what about here? Up, straight, or down? Some people saying up. Okay, I'm seeing one straight. Seeing more straights? Let's see. Yes, it's straight. And what about down here? Up, straight, or down? Some people saying straight. Up. I'm seeing more ups. Let's see. What do we see here? We see up. So all of them come together. And where is that focal point? It's actually over here. It's kind of out of the camera, so I'm going to move it and hopefully you can see it better. Actually, I got to move it this way. Nope, this way. Okay, so can everybody see that focal point? It's right over here. So you can see all of the light. Okay, my lens has tilted. All the light is meeting right over here. Does everyone see that? So that is our focal point. Okay, let me move back to our original position. Hopefully that should allow you to see everything. Okay, so now we're gonna work with some fun stuff. So let's work with the prism. What's gonna happen when I shine light through here? Up, straight, down. You can just write U, S, or D. I'm seeing some straight, S, straight. Let's see, okay. And we've got straight. What if I were to bend this a little bit? So I take this. Oh, we're seeing it's going down, huh? We're moving that because, again, the refraction is starting to happen. Okay, one last one. Oh, we have two more. The triangle. What if I put the light here? Up, straight, or down? U, S, or D? I'm seeing some up, some down, some straight, some up. Looks like everyone's kind of all over the place. Let's see. So this one's actually pretty funky. So let's take a look at this. This one is actually ending up here. So this is going through, bouncing off this side, or right there, and coming down. Does everybody see that? Let me try to move it around. Hopefully you can see it in different ways. Yeah, there we go. So our final one to try is this one. This is our Plano convex lens. So if I put it like this, up, straight, or down? Some straight, seeing some up. Let's check it out. What's happening? It's going down, and then if we keep moving it, it's going like this. So actually, a Plano convex lens works exactly like a convex lens. They're pretty much the exact same thing, because this side does all the bending, and this doesn't do much, like we saw with this one, right? This doesn't do much. So it acts just like that one. So here comes the fun part, okay? So we get to choose combinations. So we can do this, and then we can add one of these in there, and then let's add one of these in there, and maybe let's add another one, and that fell like that. And we can do all sorts of combinations, and you can see how it's going to work. Okay, so I'm going to call on someone, and they can write in the chat what they want. So who wants to go first? Okay, I'm going to see raise hand, and then I can call on you that way. Convex lens or multiples or rectangular prism or maybe triangle. So go ahead and leave that in the chat. In the meantime, who wants to go after that? So let's see. Who else do we have? Okay, so for the rest of you, all of you, can you put your answers, put your combinations in the chat so then I can make all of these? Okay, so Man Y1 wants a triangle and a rectangle. Do you want it like this? Okay, I think, okay, yes, okay. So now you guys can tell me, oh, and which color do you want? Which color laser? Do you want red, purple, or green? Purple. Okay, let's go with purple. Let me find my purple. Found it. Okay, found my purple. Okay, so my purple laser, if I point it straight, is it gonna go up or straight or down? Give me your guesses in the chat. Up, yeah, okay, up, seeing more ups. Okay, yeah, if you need to leave, go ahead. Thank you so much for coming. And seeing up, maybe some downs. Okay, let's check it out. What's happening? We're seeing it's going down because it's not actually reaching this one at all. What's happening is the triangle is taking this and bringing it down. So that might be kind of hard to see with this one. Let's see, right there. It's bringing it down right here. So right there. Okay, next one. Who's next? I see Tanya. Tanya wants a rectangular. Okay, we already did that one. Jenny wants a rectangle, a triangle, a half circle, then two curved ones. So I'm assuming you want this one. I think you might want to, and two curved ones. Okay. So two of these. Okay, this one's kind of complicated. Let's see what this does. Let's move this back. Right there, that's good. Okay, so I'm gonna flash the laser on this side. Oh, and Tanya, or who was I doing? I think I was doing Tanya's, right? Or no, I was doing Jenny's. Jenny, what color do you want for your laser? Okay, so I don't see any comments, so I'm just gonna go with red then. So red, I'm sending it in. If I'm sending it here, is it gonna go up or down or straight? Where's it gonna go? Guesses, anyone guess? Okay, yeah, some people are saying they don't think it'll pass the second one. I think that's pretty true, so down. Anyone else agree with that? Okay, seeing a lot more agrees. Okay, yeah, you're all right. It's going down there. So you all learned from that one. Nice job. Okay, so I see we have some from YouTube. So let's check out who wants things from YouTube. Okay, so from YouTube, we have someone who wants a concave and then a convex in purple. Okay, we'll do it. Okay, so I'm gonna send the light in here. Is it gonna go up, straight, or down? Let's see. Up, okay, I'm seeing some up. Yeah, I could agree with that. Let's see. We're gonna go in purple. What can you see from there? Huh, that's actually going pretty straight. Now, does anyone know why that's going pretty straight? Because this one is making it go down, and this one making it come back up. So they're actually canceling each other out. They're just having it go right straight. So that's a very nice one. And I think we had another one from YouTube. Let's see, who else did we have? We had concave, convex 6 times. All right, let's go with it. Concave, and then we have a convex, and then we have another concave, and then we have more of these. And I have 1 extra of these because I only have 2 of these. I have 4 of these. So we're gonna just go with that in purple. Okay, let's go purple. Let me find my purple. Okay, where's it gonna go? Is it gonna go up, straight, or down? Where's it gonna go? Okay, I'm seeing some straights, some diverges. Ooh, fancy language. Up. Okay, let's see. What's happening? Let's see. Can anyone tell from that? Okay, it's actually diverging. Yes, you're correct. It's going a little bit higher up here. You're not able to see it. And then like that. Let me change colors so maybe we can see it better. Okay, can we see that now? It's diverging. So yes, that is happening. It's going up, straight, and down. So that's actually pretty cool because what's happening, all of these are canceling each other out. But we have 1 extra on this side, which is making it go up, straight, and down. So yes, that's correct. Okay, okay, so anyone else have any final requests? Because we have 1 minute left. I'll take 1 more if anyone wants to do one. Okay, I see one. Okay, so this is my final one. So we're gonna do 3 semicircles. I actually only have 2, and then and 2 rectangles. Okay, I do have 2 rectangles. So we'll try that. Okay, so something like this. Okay, which color, Sammy, would you want? Okay, but I see a response, someone saying red. Okay, Sammy said purple, so we'll go with purple. Okay, laser coming in here. Is it gonna go up, straight, or down? I'm seeing converge, I'm seeing straight, seeing some up. Okay, let's see. Does anyone can tell what's happening? Yes, whoever said converge is correct. It is converging. I'll change colors so you can see better. Can you guys see that? We have a converging lens because this is making a giant converging lens. Okay, I think we have 1 final one from YouTube that I'll take, and that will be all. Let me find that. Okay, we have someone from YouTube saying, concave, convex, repeat 4 times. Okay, so I'm assuming you don't want that extra one at the end. Okay, so this one. Okay, will it go straight, up, or down? And she wants purple. Okay. Let me go see who's saying what. I'm seeing some down, some straight. Okay, let's see. Can anyone tell what's happening? Yes, we have a pretty much straight one. That's pretty straight. Oop. Okay, let's see it in red. Okay, yes, we do have a straight one. So this is canceling this one out. This is canceling this one out. And we have it going straight on. Okay, I see some new messages. Okay, so that was our final one. So I'm gonna unspotlight this and I'll come back to us over here. Move this out of the way, bring you guys closer, and we'll remove the spotlight. Okay, so let me do this. Okay, so you guys can see me again. So thank you all for coming. I had a great time teaching you guys. You're participating really nicely, even through the chat. So really nice. I hope you learned something from this. And back to this, if you have any questions about anything we did today, go ahead to our website, funscienceforkids.org. Go to the contact us button, put your name, your email, but we might have a different instructor, so be on the lookout for that, and it could be pretty fun. So thank you all for coming. Bye.
And I see there's some requests still. We're not going to do any more requests because our time's up, but thank you so much, Maida. Thank you everybody for coming, and we'll see you again soon.